let's record this. Okay, so we are writing the polynomial function. We're going to write a quartic polynomial. So a quartic, right, is to what power? 4, right. So when we're finished getting the equation, right, for our function, why did I write a squared? I just said it was to the 4th. All right, it's going to start with x to the 4th power. All right, so you'll kind of know when we're done, when we get there, because our answer will start with an x to the 4th at the front. Okay, that also tells us that we technically have 4 factors or 4 zeros. All right, now when I look at this problem, I actually only see 2 numbers. All right, and that's because the 4 is going to come from the fact that we have like multiplicities. All right, so our first 0, right, if it passes through the x-axis, it's an x-intercept, and an x-intercept is the same thing as a 0. All right, our first 0 is going to be x equals -1. All right, our other 0 is going to be x equals 5. X equals +5. Now, what we do next, right, is we have to write the factor that those zeros came from. All right, now remember the factor part, all right, is when it was like written in parentheses, what did it say inside the factor? All right, so if the 0 is the number -1, what did the factor it came from look like? X plus 1, very good. It said essentially the opposite, and they all have an x at the front, right? So they always have the x at the front. All right, and then if the 0 was +5, all right, then the factor that it came from was x -5. Very good. All right, so now we got to look at the multiplicity part. So this is where the words wiggle and bounce and pass come into play, right? Now, this one is, it just passes through 5, all right? Anytime you pass, the multiplicity is just 1. All right, and so you can, if you want, write to the first power on the outside of the factor, but you don't have to, because it's an invisible 1 that's there. All right, now, at the -1, 0, it actually says it wiggles through it. What multiplicity was wiggle? 3. All right, multiplicity was wiggle, 3 was wiggle, 2 was bounce, and pass was 1. So that means the factor where we got the -1, 0 from has to have to the 3rd power on the outside. Now, you don't have to write this out. All right, you don't have to write this out, but I'm still going to show you, okay? So that actually means, right, when it's to the 3rd power, that x plus 1 factor is being multiplied together 1, 2, 3 times. All right, and then the 4th one is the x -5, right? That only occurs once because the multiplicity was 1, right? See, this is how it has, there's 1, 2, 3, 4. This is how it becomes x to the 4th power. Aha, because there's 4 of them. Does that make sense? All right, so there's always like the same number of factors as it is going to be the highest exponent in your equation. All right, so we have to multiply these all together. All right, that's where I said bear with me. We're going to have several boxes on our paper, okay? I'm just going to start, let's just start by multiplying some x plus 1s together, right? I'm just going to do a little, we don't need a big box, right? Just 4 squares, We're going to put an x plus 1 across the top, and we're going to put an x plus 1 down the side, and we're going to multiply those two together. All right, so we've got x times x is x squared. 1 times x is 1x. This is also 1 times x, so another 1x. And then 1 times 1 is 1. Very good. Yeah, it's not bad. All right, so then we get as the answer x squared. All right, we are going to put these two 1x's together. So 1x plus another 1x is actually going to give us 2x, positive 2x, and then a plus 1 on the end. All right, now we got to keep going. So we've multiplied these two. All right, let's take this answer, and we've got to multiply it with the next x plus 1. We got one more of these to do, okay? So, all right, we're going to make, now we have a little trinomial, and we're going to multiply it times a x plus 1 binomial. So we're going to have six squares in our rectangle to multiply those. All right, so x times x squared is x to the third. 2x times x is 2x squared. 1 times x is 1x. All right, 1 times x squared is 1x squared. 1 times 2x is 2x, and 1 times 1 is 1. All right, so let's go see what we can combine. So the x to the third is the only thing that has a third power, so that's going to go at the front. X to the third. See, we're not quite done yet. You know we're not done because we haven't gotten to x to the fourth yet. All right, now we're going to put these, there's a couple of x squareds that we can combine. 2x squareds and another 1x squared, so plus 3x squared. All right, also a 2x and a 1x right there, so plus 3x, and then a plus 1 at the end. All right, what's going to be our last step?
It's going to be 4 spaces.
What's going to be our very last step that we have to do?
That's going to be x minus 5.
Yep, we got to multiply it with one more thing, the x minus 5. All right, so yes, our box gets even a little bit bigger because now we have these 4 terms here, right? So our box is 8 squares now, our rectangle. All right, and I'm going to put x minus 5 down the side because that's the last thing we have to multiply it with. And look, here's how we get the x to the fourth. X to the third times another x becomes the x to the fourth that we'll need in our final answer. All right, 3x squared times an x is 3x to the third. 3x times an x is 3x squared. 1 times x is 1x, halfway there. Negative 5 times x to the third is negative 5x to the third. Negative 5 times 3x squared. So negative 5 times 3 is negative 15. And then it's going to have the x squared on the back of that. All right, this is going to be negative 15 again with just an x on the end. So negative 15x. And then last but not least, just numbers. Negative 5 times 1 is negative 5. Okay, Let's see, the x to the fourth is the only x to the fourth, so that goes at the very front. All right, we're going to put together these x to the third powers. Notice the things you put together, they're always like diagonal from each other somehow. All right, they're always diagonal squares.
It's like the front and then the caboose.
Yeah, exactly. Okay, so negative 5 and positive 3 is negative 2. Negative 2x to the third minus 2x to the third. All right. Then negative 15 and positive 3 of them we're putting together. Negative 15 and positive 3 is going to be negative 12. Negative 12x squared. All right. Negative 15 and positive 1. Negative 14x. And last but not least, the negative 5 hangs off the end. This is your whole equation. The entire quartic equation that would, if we graphed it, ooh, should we graph it?
You should graph it.
You want to see what the graph looks like?
Yes.
We might have to do that at the end because I think it'll stop my video. I don't know. I think it's only recording the document camera and not my computer and not the whole computer screen if I show Desmos. We'll graph it at the end. We'll do the other problem, stop it, and then go see. We'll go look at the graph and see if it actually wiggles through negative 1 and passes through 5.
That's doing a hex.
It should. I'll type in this equation and our graph should actually, you can actually see the wiggle through the x-axis at negative 1, and you should see the line just pass through the x-axis at the number 5. All right, this one's going to be way easier.
Just 2.
Yeah, it's a quadratic. So it's only the highest part of the whole equation is just going to be x squared, right? A quadratic is just an equation that starts with x squared. All right, so it's going to be way less multiplying than it took on this one to get it all the way to be a quartic, an x to the fourth. Like, I think we might only have to do one box. All right, there is only one x-intercept. There's only one 0. Our 0 is at x equals 9. Okay, what's the problem with that, though? There's only one 0, but we have to get it to be x squared, right?
Yeah.
So let's see. All right, what's the factor that the 0 x equals 9 comes from?
Negative 9.
Yep, x minus 9. All right, so that would be it. There's nothing to multiply it with. Wait, but is that going to give me an x squared equation? All right, so they didn't say this. All right, but what would it have to do? It just says there's one x-intercept, all right? But there would have to be a multiplicity, right? And it didn't say if it passed, bounced, or wiggled, but what would it have to do if it's going to make a quadratic?
Bound.
It would have to bounce. That's right, right? An x squared graph is a parabola, all right, is a parabola. And if there's only one x-intercept, right, it would be because that x-intercept is the very bottom point, right? So they're basically telling us that this is the 9, all right? And so if we want it to be an x squared graph, right, it would have to actually bounce off that point. So this x minus 9 has a multiplicity of 2, and then you actually have something you can multiply together. right? You would just do x minus 9 times itself, because that's what it means when something is squared. There's two of them being multiplied together. All right, but that's not hard. All we have to do is one little box for this one to multiply x minus 9 times x minus 9.
Not 4 boxes.
No, we don't need to do, well, the last one we did 3 different boxes, right? All right, we only have to do one box, and we should get an x squared equation. All right, and it'll actually be the equation for this graph right there.
Yeah.
All right, so x times x is x squared. Negative 9 times x is negative 9x. This one's also negative 9 times x, so negative 9x. And then the end is going to be negative 9 times negative 9, so positive 81. All right, so our final equation, I'm going to throw a y equals in front of the whole equation. X squared at the front, as we knew it should be. It should start with y equals x squared. All right, we are going to put the negative 9 and another negative 9 together. Negative 18 x, and then our plus 81 at the end. There's our quadratic polynomial. Nice. That one was way shorter than the last one.
We just got our answer without doing too many boxes.
Yeah, one box. We were good. All right. One more back to a quartic, but this one's actually going to be easier. We're actually only going to have to do 2 boxes. I'll show you why. All right. So we are going, last problem, we're going to write a quartic polynomial again. All right. So it's going to start with y equals x to the 4th power when we're done. Right. And it has 3 different zeros. 3 different zeros, and the function's going to bounce at the origin. So the bounce is going to be a multiplicity of 2. So one of these is going to occur twice, right? The other ones will just have a multiplicity of 1. All right, so let's list out our zeros. All right, so there's a 0 at x equals negative 7. There's a 0 at x equals 0, and there's a 0 at x equals positive 3. All right, so we want to write out the factors that those zeros come from. Turn our zeros into the factor in the parentheses. So if it's negative 7, then it came from x plus 7. Is what the factor looked like. Now, this one's kind of tricky, right? Because 0 is not negative or positive, right? So when you like reverse, like this was negative, so we changed it to plus 7, right? You can just say x plus 0, all right? But even better than that, here, I'm going to write this with pencil for a reason, all right? Do I need to even write plus 0? Does that mean anything?
No.
No, right? So what could I just put as the factor?
X equals 0.
Or just x,
X.
right? It really is x plus 0, right? But are you ever really going to does anyone write plus 0 in the equation? We insert it sometimes when they didn't write it because they didn't write it, and we're like, we kind of need a 0 there, all right? But you don't have to write the plus 0 at the end because, like, it's kind of nothing, right? Let's just write nothing there, right? So it's just an x, right? So you don't have to write an x plus anything or an x minus anything. The factor is actually just x. Right? If you think about it, the factor when it equals 0 tells you what the 0 is. When x equals 0,
Yes.
that's the 0, right? It's 0. Okay. All right, and then this one we do have to write in its parentheses though. All right, it's going to be x minus 3, the opposite. The 0 was positive 3, so the factor is x minus 3. All right, and then one of them bounces. It bounces at the origin. What number is the origin?
X. Good.
The 0, right. Number 0 is the origin, right, on your graph, 0, 0. All right, and so that one is going to bounce, so it's going to have a multiplicity of 2. So we're going to put a squared on the outside, so we're just going to call that factor x squared.
2 X's.
That's the x, yeah, it's technically 2 x's multiplied together, right? So you've got 1 factor, 2 factors, 3, 4, right there. That's how it becomes the quartic, yeah. All right, so actually the only box I think we need is because we have to multiply the x plus 7 times the x minus 3 part together.
That's
All right,
the
I would just do that first, all right, because that's the part where you actually would need a box to multiply them. We'll multiply it with the x squared in a minute when we're done with that part. So we're going to do x plus 7. It doesn't matter which order you multiply them in. I just always usually pick the first 2 or just whichever's I want to knock out first. So we're going to do x plus 7 times x minus 3. All right, so we're going to get x squared. 7 times x is 7x. Negative 3 times x is negative 3x. And then negative 3 times positive 7 is negative 21. 7 times 3 is 21. All right, so that written out, x squared goes at the front. All right, we're going to put these diagonal boxes together. A positive 7 and a negative 3 is positive 4. So plus 4x. And then your minus 21 at the back. All right, now, check, check. We multiplied that together. The only thing we now have to multiply with is the x squared. And we don't have to use a box for it. We need to multiply all of this, right, times just an x squared. Now, we can do that. We can do that just by doing a basic distribute it all the way across. Because, I mean, you could use a box if you want to. It would be a 3 by 1 box, right? So only like 3 squares. But you could also just say, okay, what's x squared times x squared? What's x squared times x squared? X to the 4th. There's where we get the quartic part from. Right? Okay, now we got to do x squared times 4x. So that's going to be 4. And the x times the x squared becomes x to the 3. Yep, third power. All right, and then last but not least, x squared times negative 21. That's going to be negative 21 x squared.
What about the singular x?
There doesn't have to be one. There's not one. That's the equation right there. I can throw a little y equals in front of it. It is a quartic equation. All right. It just has a 0, x to the first powers, and 0 as the constant at the end, right? So they didn't have to write it because it's zeros, a bunch of zeros. All right? So that's the last one. All right. Let me stop this.